Hello scholars! In this set of videos we're going to explore section 2.4. It's the last section in chapter 2. It's called Average Rates of Change and Tangent Lines. So I think you'll need this document here that you see projected. It's available on the Moodle. If I'm not mistaken, you can also touch it right in the video and download it. You'll also need your textbook open to page 87. Don't forget to fill in your notes sheet as you go along. So we want to talk in this section about how we can measure the way functions change. So you used to be able to measure how linear functions changed by measuring the slope. But linear functions are the only kind of functions that always have the same kind of change. So we want to be able to talk about change for functions that are more exciting. And there's two ways in this section that we learn to do it. One is with the average rate of change. So I don't see that the formula is anywhere in your book, so you might like to write this down. The average rate of change of a function f of x over the interval a to b is given by f of b minus f of a over b minus a. That should look like change in y over change in x. So we have two examples from your book we're going to do just to practice this. It turns out to come up really quite often in calculus and even on the AP test. So example 1, I want to find the average rate of change of x cubed minus x over the interval 1 to 3. So you can see that in this problem, standing in for b is 3 and standing in for a is 1. So here's what we do. We're going to plug in 3's everywhere we see b in this expression for average rate of change. We're going to plug in 1's for a's. Oops. That's what I meant to do. Okay, so f of b minus f of a over b minus a. I'm going to take the 3 and cube it and subtract 3. That's x cubed minus x when x equals 3. And then I'm going to subtract 1 cubed minus 1. That's f of a when a is 1. And in the denominator, b minus a is 3 minus 1. You can multiply that out. 24 minus 0 over 2 makes 12. So the average rate of change of f of x over the interval 1 to 3 is 12. Notice this critically important, not in this problem, it didn't matter, we ended up subtracting 0, but this distribution, this subtraction sign, if you don't distribute it, you're going to make the most common calculus mistake there is. So don't fall into that trap. Make sure this subtraction sign gets distributed, or make sure anything that you want to evaluate, in this case f of a, that comes after the subtraction sign, goes inside parentheses or brackets. The next example is example 2. It's right there from the same page. One of the powers of average rate of change is it's not just the same as calculating slope given 2 points on a curve, but we can start to understand what the units mean in this case. So use points 23, 150 and 45, 340 from this figure. So check out the figure in your textbook, page 87, to compute the average rate of change in the population of fruit flies that they describe there in that problem. So we're going to use the same expression, f of b minus f of a over b minus a. Here we don't have a function f. We've already been given the ordered pairs. So change in y over change in x, I'm going to have 340 take away 150. What are the units on both of those values? They're fruit flies. So whenever possible, keep the units with your values when you find average rate of change. In the denominator, b minus a is 45 minus 23. That's measured in days. So simplify, we get 190 fruit flies in 22 days, and that just simplifies to 8.6 fruit flies per day. That's the average rate of change of the fruit fly function over the time interval 23 to 45 days. Now hopefully you'll recognize what we did here is the exact same thing we did in 2.1, back in section 2.1, when we wanted to compute average speed. So change in distance over change in time. Just notice this idea applies to all kinds of other functions, not just distance and time. Right here, if you'd stop the video, or the video is going to end, make sure you read page 88 in your book before you watch the next video.